Hey, Dan. Okay, so I just want to give you some commentary as I go through the raw footage here that we're going to capture. To start with, this is the actual use case that we're running up right now that we want to show basically a live demo of, and we'll be doing a live demo of this essentially at Ignite as well up on stage. So what we're looking at here, as you can see, is we have three environments. We have our on-premise domain controller, or excuse me, our on-premise data center. We have our West Coast Azure environment as well as our East Coast Azure environment. Inside those environments, we are actually providing layer 4 through 7 services. We're doing load balancing, authentication, as well as a layer 7 firewall functionality through our ASM. And we're doing that for all the environments. As you can see here on each location, we have two big IPs that are bouncing traffic for a series of farms, West Coast, East Coast, and on-premise web services. We're using for authentication, we're using SAML authentication. So rather than having to have a authentication mechanism, in other words, like a domain controller that's replicated up in West Azure and East US Azure, and all the underlying architectural requirements for that, we've really simplified it using just federation. This is kind of a nice way to do it. So we can still provide authentication at all the environments, but really our authentication method is all being handled by our on-premise data centers that are providing SAML federation. So the big IPs in Azure are the SAML service providers, or configured as SAML service providers, the big IPs. The big IP on-premise is configured as a service provider as well, with an additional big IP that's providing SAML federation IDP, or identity provider functionality. So what we can do here is we're going to test the connectivity between the environments. We're using GTM as well, so we have a GTM on-premise and a GTM in East US to give us a presence on both sides of the continent. Probably best practice would be to have GTM in all the locations, though it is not required. So the whole purpose of this is to show that A, you can do this without having to have a GTM deployed everywhere. And still get the same functionality. In addition to that, our on-premise environment is on the West Coast, so we basically are essentially killing two birds with one stone as far as geolocation services go. Right now, our GTM is configured to straight for round robin, at least connections, so we can show the traffic going back and forth. But it kind of gives you an idea of what we can do. So let's take a look at how this looks in Azure. If I can find my mouse. Alright, so up in Azure, we have several virtual machines. As you can see, we have, on our East Coast, we have two big IPs, our East Coast GTM, as well as 3 web servers. On the West Coast, we have two big IPs. I already have configured another GTM. Once again, for this demo, we're not going to utilize that GTM. And then we also have 3 web services as well. We very well could use another GTM device, but for simplicity's sake in testing, we're just going to keep that one disabled. All right. And here is our East Coast GTM as an example. We're using this for, once again, providing that global traffic management, where we're able to load balance traffic not only across our on-premise environment and our Azure environments, but we can use GTM to provide load balancing across all the environments, whether it's Azure, whether it's on-premise, whether we're including another cloud provider such as AWS. So in case a customer wants to basically have a presence in both different clouds as well as on-premise, we can do that all through GTM, done the exact same way. So in this case down here, we're looking at the pool members. So this is the pool members for our web service that GTM is going to provide DNS resolution for. We'll do a real quick here example to show. Do an NSF lookup for test.f5